Good evening, or good morning, or good afternoon, or if you don't know what time it is, hello. This is Mr. Hess. Um, Hopefully everybody's doing okay. I know it's a tough time of the year, but we're getting closer to the end of this in more than one way, and hopefully the next year will bring us some new joy. Um, this next discussion is about same thing you've been doing the last couple of classes, talking about proportions, but now we're talking about two different proportions. So comparing two different groups. So to start this, there's sort of a couple warm-up questions on your paper. If you printed this out, if you don't print this out, just do some work on a separate sheet of paper and submit that to Schoology at the end of this. These example problems are on a PDF format on Schoology. So this first introduction question, again, we're comparing proportions. Eventually, we do confidence intervals, hypothesis testing. Give you a new formula in a minute here. Pause the video, take a minute, see if you can figure out 1, 2, 3, 4, these 5 examples, whether they're referring to a single proportion or a difference in two different proportions. The trick to analyzing these, in my opinion, think about the denominator you would use when you're comparing these two proportions, because some people, when they read through this, they're going to say they're all difference in proportion. I'm just telling you right now, they're not at all a difference in proportion. Some of them are a single proportion, just being looked at from the left side versus the right side. So again, pause that, read through these examples, come back in a minute. So hopefully I had a chance to give these a try. We'll talk through these real quick. The first one here is proportion of males who voted for Trump versus compared to the proportion of females. So technically that is what we're looking for. That's a difference in two things, difference in two proportions. You're looking at two different groups, a male group versus a female group, and those two separate proportions can be compared. So hopefully that first one makes sense. That's fits right up this alley. The next one is not a difference in proportions. We're asking 40 people what their favorite fruit is, and some said apples, some said oranges. If you think of the proportion of people that said apples and the proportion of people that said oranges, they're going to have the exact same denominator. This is some number out of 40, and this is some number out of this exact same 40 people. So because you're looking at the same denominator, that's a single proportion. We're just looking at two different, or the same groups, another way to think of that. The methods we're going to use in this section have nothing to do with that. That's what you did in the previous section. So different method if you're going to analyze that. Third one, proportion of votes for Trump versus Hillary. That's a classic example of a single proportion. Maybe it's, 50, well, it's less than 50% voted for Trump, but, 48% voted for Trump and 49% voted for Hillary, something like that. You're looking at the same denominator in both those cases. It's all of the total voters in the U.S. The fourth one compares a proportion of MMU students who play a sport to the proportion of that same type of proportion at CVU playing sports. So let's say, 62% of MMU athletes play sports, and 53% of athletes, of students at a CVU play sports. That's two different proportions you're looking at. They are coming from two different groups. You're looking at MMU students, some percentage, and CVU students, some percentage. Some percentage of those students are athletes or jocks, as they say. And you're comparing two different proportions for those. Hopefully that makes perfect sense. The last one, if you want to look at the percentage of students who shower in the morning versus night, that's a single proportion. You're looking at the same denominator for both of those. They're both referring to MMU students. Another way to think of these is, are you comparing two different categorical variables? This is only one categorical variables, showering the AM versus showering the PM. This is only one, voted for Trump or voted for Hillary. It's only one category. There's different options in that category, but it's only one category, as opposed to gender up here or sex up here and who they voted for. Down here, school they went to is one variable. The other variable is whether they play sports. So these, there's got to be two variables you're comparing to apply these new formulas that we're going to show you here in a minute. So definitely write these down. These are important. when we're looking at a difference in proportions, same formula you used in the last section, except now there's two parts to it. Instead of just having one of those, it's got a whole other part of that. And to delineate between these, when we're finding a standard error in this group of, this difference in proportions, we want to differentiate between sample group 1 and sample group 2. So we put those little subscripts in there, ones, 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 and we do the same thing on the other one with 2s. Now you might be asking yourself, if you're actually looking at this and thinking about it from that, you might be asking why there's a plus sign right there. There just is. It's beyond the depth of this course. We just want you to know how to use the formula, not where it comes from. It's a pretty high level way to derive that formula. Last part of this is just checking sample size. So you're still going to apply those two formulas like you did in the last sections, but you do have to check it for both P1 and P2. In other words, this group and that group have to have enough proportions. They have to meet that rule of 10. At least 10 members qualify. So try to see if you can apply this formula on the next one here. There's a few questions about it, and I'll be back in part 2 in just a moment.